After completing this video, you will be able to explain what Building Information Modelling or BIM is, describe how BIM connects multidiscipline teams, and explain how the common data environment is fundamental to efficient collaboration and project progress. Have you ever thought about how large buildings like schools, colleges and universities are designed, constructed and operated? Or how different people or different teams from different companies can work together to deliver a new building? It's not just about the work that we see on a construction site. To drive project efficiency, reduce waste, save time and deliver better outcomes, before construction can begin on site, projects benefit from smart planning and collaboration from all of the specialist disciplines. In the past, each company worked independently, creating and sharing 2D drawings with other companies. And as they worked to different processes, there were some barriers to how they worked together. Modern construction projects benefit from Building Information Modelling or BIM. BIM is a process that connects specialist disciplines such as architecture, structure and building services, guiding all of the various teams through all stages of the project so that they can collaborate efficiently to design, build and operate buildings and infrastructure. Each of these specialist teams contribute their expertise. Architects design how the building will look and function. Structural engineers add the structure, the frameworks and supports to make the building strong and safe. While mechanical, electrical and plumbing engineers ensure that things like water, heating, cooling and lighting systems all work properly. To allow these teams to work together or collaborate, everyone needs to work to the same processes and standards. And this is where BIM helps. BIM is a standardized process. A process that defines how all stakeholders or people working on a project should work. It defines what information is needed from everyone, when it is needed, and how it should be shared, such as file format and which folder that should be in. Think how confusing it would be if one company worked in a way that was different to the others. It is this standardization of the BIM process that allows everyone to work together to design, construct and operate a new building. One small example of this standardization can be seen in the naming of files. During the design stage, there are hundreds of files created and shared, including reports such as the Environmental Impact Report, drawings, 3D models and other files. Imagine you need to find the Environmental Impact Report or the Architectural Model to allow you to design your 3D structural or building services model. Just now, this may be difficult as you may not understand how the naming standard used in this example works. The standardization of the BIM process defines folder structures, naming convention for files so that everyone saves their models and other files using the same method to an expected folder, making it much simpler to find the information you need, saving you time, which ultimately saves your company and your client money. One of the key outputs of the BIM process is the 3D model. However, a 3D model doesn't just show how the building will look. The word information in Building Information Modelling relates to the information associated with the physical and functional characteristics of the individual elements within the 3D model. Information like wall construction, which includes details such as materials and thermal properties, enables the architecture team to analyse energy consumption early in the conceptual design phase using tools like Autodesk Forma. Another advantage of the BIM process is the ability for teams to use other disciplines' 3D models. In a BIM project, the structural team can use the architectural model to help them design the structural model. This is called coordination. One example would be the building services team using both the architectural and structural models to design the most efficient route for air conditioning ducts, lighting and other services. Using the structural model to avoid columns and structural framing, while using the architectural model so that they can locate light switches near to doors and lighting or air conditioning units within the necessary rooms at ceiling height. And this collaborative process ensures that each team can design with the bigger picture in mind, and it also means any coordination or design issues can be discovered in the 3D model before construction begins. Time on a construction site is very expensive, especially if it's being spent fixing mistakes like a door installed where a column should be, or a pipe passing through a beam where there is no opening for it. By using the other disciplines' models to design, all of the disciplines work together to remove issues in the 3D models and ensure time on construction is smoother and reduces waste. Historically, the individual companies worked in silos, storing files locally on their internal company servers and sharing them through emails, which often led to confusion, duplication, and delays as people in the other companies requested information. With a need to collaborate, work together, and share models and other files, BIM has changed this workflow by introducing a Common Data Environment, or CDE. The CDE, in this example, is the Autodesk Construction Cloud, a cloud-based, centralized workspace where all project files, 3D models, drawings, reports, and other files can be stored and accessed by all disciplines whenever they need them, removing the need to request information from other disciplines by email and wait for it to be shared, saving time and moving from a silo workflow or individual working to a collaborative one. It also means that the information being accessed is the latest version and up to date. Common data environments, like Autodesk Construction Cloud, also bring advanced coordination tools that somewhat automate the coordination process. As each discipline works on its own model, tools like Model Coordination in Autodesk Construction Cloud combine these into a single multidiscipline model, and this process is known as federation to check coordination automatically. By identifying issues early, teams can collaborate to determine the best solutions. Ultimately, the standardization of the workflow by the BIM process makes it easier for multiple disciplines to collaborate, helping to deliver better outcomes. And by working together in a shared digital space, the teams can create more cost-effective designs, reduce issues on site, and ensure smooth construction and efficient use of the building. BIM isn't just about designing a building, it's about bringing teams together to make the process smarter, more efficient, and better for everyone involved.